right, we're looking into week 2 here with section 1.2, and this is all about linear equations and rational equations. Don't forget, rational is just a fancy word meaning a fraction, so we'll have some with those in them. So let's kind of take a look here at what a linear equation is in one variable. It's an equation that can be written of the form, oops, get my pins on here, sorry. ax plus b equals 0 is that equation, where a and b are going to be our real numbers, and a here cannot equal 0. So we have to have something with an x for it to be a linear equation. Now, in order to solve that equation in x, meaning the variable that you're using, involves determining all the values of x that result in a true statement. These are what we call solutions to our equation, or sometimes they're referred to as roots, but what makes that value true for the equation. For example, if I have x equaling -3, if that's a solution of this equation, that basically just means that if I replace the x with the number that it's saying is a solution, then we should get a true statement here. So it should equal 0. Well, does it? 4 times -3 is -12, plus that 12 does equal 0. Therefore, -3 is definitely a solution to that equation. Okay? So here's some basic steps in order to solve a linear equation for you to use. Basically, we're going to simplify an expression by removing any grouping symbols, combine like terms, get it as concise as we can. Then we're going to add or subtract the same real number or a variable expression on both sides of the equation. Then we're going to multiply or divide by the same non-zero quantity on both sides. So one thing that you want to remember when solving an equation, you must do the opposite operation, and what you do to one side of the equation, you must do to the other side to keep it balanced. That equals means things have to be balanced. So if we look at this first one, 4x plus 5 equals 29. Well, my idea is I have to get this letter x by itself. So I'm going to this helps you kind of split it to two sides with that equals. Then I want to get x by itself. Well, notice I have this plus 5 hanging out here. If I could get rid of that, then I'm one step closer to getting x by itself with that 4. So the opposite of addition is subtraction. So we are going to subtract 5 from both sides. What you do to one side, you must do to the other. Now, this 5 minus 5, that goes away to 0. And that's kind of our goal, is to kind of get that x by itself, get things that cancel out. So now I'm left with 4x on the left. Bring your equals straight down, do this operation, which gives me a 24. And then we have to realize that this is actually a product here. 4 times x is what that means. So in order to undo a multiplication, the opposite operation is to divide. We symbolize that with a fraction bar. So divide both sides by 4, or the number next to the letter. 4 divided by 4 cancels itself out in the sense that it becomes a 1. So basically all I'm left with is just an x here, equals 24 divided by 4, which gives me a 6. Therefore, x equaling 6 is my solution. And so again, that's kind of one basic two-step equation that hopefully from Algebra 1 and also some stuff in geometry you would master that. All right, let's try this one. It has a grouping symbol, has a minus in front. Remember, there's an invisible one there that you don't see, but we must distribute that negative through to get rid of our grouping symbol. So I'm going to do that. -1 times a positive 2x gives me a negative 2x. -1 times a negative 10 gives me a positive 10, equals 35. Now, let's combine on this side as far as we can, if we can, which we can in this case. 5x minus a 2x gives me a 3x, plus a 10 equals 35. I'm just going to rewrite those, and now I get back to exactly what we just saw in the previous problem. If I want to kind of group two sides here with the equals, the left side is one side, the right side of the equals is the other. Let's get rid of this plus 10 by subtracting 10, again doing the opposite. That goes away. I'm left with 3x on the left. 35 minus 10 gives me a 25. And I'm going to Undo this by undoing that multiplying by opposite of dividing both sides by the number next to the letter. Therefore, this goes away, leaves me with just the x, and unfortunately, this 3 won't go into that 25. So the best I can write it in an improper fraction is 25/5. Okay? All right, the next one. I've got x's on both sides, numbers on both sides, so we want to kind of separate that. We want to get the x's together, get the numbers together, and see what we have. So here, I'm going to choose, for whatever reason, I always like to get the x's on the left, so I'm going to bring this x over by doing the opposite. Now, that's a plus x. I don't see a plus there, but it's assumed to be a plus, so if I subtract x, x minus x here goes away. Now, you can do it one step at a time, and I'll do that here for the first one, but I might kind of do multiple steps in one later. So if I do 3x minus x, I get a 2x. I'm going to bring down that plus 5, and I'm going to have that equal to what's on this side, which is 13. Now, again, that gets me right to where I started with in the last two problems, or ended up getting to. Here I got to this point. So I'm going to do the opposite here. I'm going to do the minus 5, get rid of that. Then this cancels out. I'm left with just a 2x on the left side. And 13 minus 5 gives me an 8. Therefore, one more time, just like before, divide by the number next to the letter. So if I divide by 2 both sides, x here is equal to 4. And that's going to be one of my solutions. Okay? All right, let's keep moving. What happens if I have 2 sets of parentheses here that I need to work with? I'm going to end up getting rid of both of those at the same time. So let's multiply in, which gives me a 2x minus a 2. I'm going to rewrite that plus 3. I'm going to rewrite this x because I have to take this negative 3, 2 to both of those. So negative 3 times x is a minus 3x. Then I get a minus 3 when I multiply negative 3 times a positive 1. Again, clean up as much as you can on these sides. So notice here and here and here and here. Whoops, sorry, undo. Let's undo that. Because those two things didn't go together. These two things go together. Whoops, I went too far. Let's rewrite my 3x minus 3. And then on this side, these two things are going to go together. Okay, so on the left, rewrite the 2x. Then I have a minus 2 plus 3 gives me a positive 1 equals x minus a 3x gives me a minus 2x minus 3. And now, just like before, go side to side. I'm going to end up adding this 2x to the other side. Okay, for whatever reason, I always like to have that x on the left. I'm not sure why. I'm just used to it. 2x plus 2x gives me a 4x plus 1 equals this negative 3. Don't forget your negative there. And then again, we're 2 steps away where I end up having to, all the ones I have are pluses, so I should make one of these a minus, but it's a plus 1, so do the opposite, which is to subtract 1. I'm going to bring that kind of up here. On the left side, this goes away, so I'm left with 4x equals negative 3 minus 1 is a negative 4. Divide by the number next to the letter. Excuse me. Which that should be a positive 4. It looks like a negative 4. Therefore, negative 4 divided by 4 is a negative 1. And that's going to be my final answer there. All right, so the last of our linear equations before we get into our rational equations gives us, again, 2 places there that I have to distribute through. And so I'm going to do that with this negative. It's going to go through each one of those. This plus with a positive 1 in front, hopefully you realize, does not actually make a difference here. So I'm going to have 5x minus a 2x. And then a minus 2, make sure you distribute that negative through each one of those, equals, rewrite the x, and I'm just going to rewrite this expression by itself because that parentheses doesn't make a difference with that plus in front. Okay, I'm going to combine these two things here, gives me a 3x minus a 2, and then I'm going to combine these two x's terms here, gives me also a 3x and then a minus 5. Now this one's actually a little bit special because what happens when I start subtracting, let's say I subtract this 3x from both sides. When I do that, this cancels out as well as this cancels out. Both of them go to 0. So what I'm left with is negative 2 equals a negative 5. Now, we should ask ourselves the question, is that true or is that false? Well, hopefully you're screaming at me saying that it is actually false. And so, because of that, if it's being false like that, things cancel with the x's. This tells me mathematically that no answer will work. There is not an x value that will satisfy that equation. Therefore, we say that the answer to this is the empty set. Okay? All right. Now, let's turn our attention from these linear equations now into some rational equations, okay? Rational equations are like these guys that are down here with these fractions. And so, if I want to go into those, the first thing I want to do is kind of get rid of those fractions. And in order to do that, what I want to determine is the least common denominator. Okay, sorry, this pen's a little slow here. All right, the least common denominator is going to be the key to this in order for us to get rid of those fractions first. So, if I look at this first example, I notice that I have a 5 and a 6 in the bottom. So, I want to figure out what is the least common denominator, what's the smallest number that both of those would go evenly into. Well, I'm hoping you're telling me that the least common denominator here is going to be 30. And when I know that, now I'm going to multiply every term by 30. You have to make sure that you're fair on every single one of these terms. So now it's like I have 30 over 1 there that I can cross cancel the 5 into the 30 and leave me a 6. Now it's not only a 6, but it's multiplied by what's on the numerator part there, which is 6x. Likewise, on my second term, 6 goes into 35 times, and now I want to multiply it by that x, and I get a 5x. And then I have this product, which is going to give me a 30. So now I have an equation that's just like before with those linears. I don't have any fractions. I can solve it. Let's combine our x's by subtracting the x from one side. Goes away on the right side. I'm just left with x equals 30. And our task is to get x by itself. Therefore, I'm done when I got to that step. So x does equal 30 here. Okay? Now, the next one, between 4, 14, and 7. Now, I have some expressions on top. You want to be very, very careful there. And also with this negative, you want to be very careful. So, between 4, 14, and 7, the least common denominator, hopefully you're telling me, is going to be 28. So I'm going to multiply every term by 28 here. And in this case, something's going to cancel with each one of those because I have a fraction on each term. So the 4 will go into 28 7 times that I must now distribute through that expression. The 14 will go into 28 twice that I have to multiply by that 5. And the 7 will go into that 28 4 times that again I have to multiply by that expression. I'm going to be distributing, but notice here it's a minus, so it's like you're taking a negative 4 through each one of those. So be very careful. Let's do 7 times x and 7 times 3 to get a 7x minus a 21. Set that equal to 2 times 5 gives me a 10 minus negative 4 times x is a minus 4x. Negative 4 times a positive 5 is a negative 20. And there is my equation. No fractions, but now we're going to be able to solve that. I'm going to go ahead and combine these two things here. 7x minus 21 equals, I'm going to bring this in front, negative 4x, and 10 minus 20 is a negative 10. And if you're having trouble with that, make sure you check it on your calculator. All right, let's add 4x here to the other side. And here's where I'm going to kind of do it all in one step. This goes away from here. I'm eventually going to have to take that negative 21 over. So do the opposite of minus 21, which would be adding 21. Remember, what I do to one side, I must do to the other, and it must be opposite. So here, these are going to cancel from this side. So now I'm left with my variables and just my numbers. So this gives me 11x. And negative 10 plus 21, or 21 minus 10, however you want to look at it, is 11. Divide by the number next to the letter. Therefore, x equals 1. That's going to be our final answer. Okay? All right, very good. Let's move on to the next page of section 1-2 on rational equations. Actually, these are going to be the equations are ones with fractions that have variables in the denominator. The two that we just saw just had numbers, but this time we're working with variables in the denominator. When working with fractions, one has to make sure they remember one important rule about fractions. One cannot divide by 0. That is very important to remember. Therefore, when there are variables in our denominators in the bottom, one must ensure that the variables they claim are solutions are actually ones that do not make the denominator equal to 0. So here we're going to just practice by looking at a fraction and saying, okay, if I were to determine what values to take out, what makes this denominator 0? So the question would be, can I set the bottom equal to 0? Most definitely. And I can solve that for x. And so when I divide by 3 and divide by 3, x has to equal, well, that goes away. 0 divided by 3 is 0. It's not 3. So that, if I had x equaling 0, that would be the number to make the denominator 0. If I look at this guy, x minus 3, what makes that equal to 0? Well, you could ask yourself, what number minus 3 gives me 0? You might be able to pull it out of the top of your head, which is fine. You can also solve this equation by adding 3 to both sides to definitely know that x equaling 3 makes that denominator 0. So when solving these types of problems, we want to exclude those numbers out from our solution. What makes this denominator 0? Again, you can set it equal to 0 like we just did here, but we can also just ask yourself, what plus 7 gives me 0? Well, hopefully, working with your integers and stuff, you would tell me x equals negative 7. So you can go ahead and just write that if you see it. You don't have to write this out and solve the equation, but if you're unsure, you definitely need to do that. So solving gives me x, 0 minus 7 is a negative 7, would make that denominator 0. Again, those are the values that we can't have as solutions for these next type of problems, okay? So the idea is the same as what we just did in the previous two problems, where we want to multiply by our least common denominator. But in this case, we have variables, so we have to look out for the expressions, and we have to look out for these guys up here to make sure that none of these answers that make our denominator 0 are part of our solution set. So let's look at this idea to solve some fractional equations. Find the value which makes the denominator 0. So if we look at this and look at this, what number do I throw in here to make this 0? Don't make it too hard. That would be 0. What number times 3 is 0? That would be 0. So here on part A, x equaling 0 is going to make the denominator 0. So if I get that as a choice when I solve out this problem, I'm going to exclude that. We can't have that as an answer. Keeping the restriction in mind, solve the equation. So notice, here I have an x, here I have a 3x. To get my least common denominator, we need to make sure we have factors of all. So with the numbers, 3 is going to be the least common denominator since that's the only one. And when I have an x and an x, that's going to be part of my least common denominator. So least common denominator here is 3x. So that might be hard at first, but we'll work through it. All right, so if I multiply by 3x, multiply by 3x, and multiply by 3x, we're going to get rid of our fractions. These x's are going to cancel. So I'm left with 3 times 5, which gives me 15, equals. This 3x is going to cancel all of that 3x, so I'm just left with my 10. And then here, 3x times 4 is a 12x. Now I have an equation that I can solve. So I'm going to get x by itself by getting rid of this piece here. Now that's a plus 10. It's kind of odd when it doesn't have the sign, but remember it's supposed to be a plus. I'm going to subtract those out. I'm left with 15 minus 10, which is 5, equals 12x. Then I'm going to divide by the number next to the letter, which divide by 12. And notice this fraction can't be reduced. Therefore, this is my possible answer. Now I say it's a possible answer because you have to compare it with this up here. Did I get an answer of x equaling 0? No. So this is okay. If I would have got x equaling 0, I would have had to have excluded that out because that's a not allowed number per the domain. All right, let's look at this next example between 2, 18, and 3. Look at the numbers first, then deal with the letters. 2, 18, and 3. Least common denominator there with the number. Hopefully you're telling me 18. We'll go into all of those. If you have an x and an x, we need one of those. Now, if you had an x and like an x squared, we would need to take the higher of the two powers. You take the greatest power of any variables, okay? So here, 18x is what I need to multiply each one of these by. All right, so if I do 2 into 18, that goes 9 times. The x's cancel. So I'm going to have just 9 left over here, multiplied by that 5 gives me a 45. This 18 will cancel that 18, and I'm left with 17x minus, x's will cancel here, and 3 will go into 18 6 times that 1 gives me a 6. And so again, here I have a two-step equation, so important to know how to solve those. I'm going to get the variable by itself by adding 6, and I'm left with 17x on the right, and 51 on the left, divide by the number next to the letter, and that gives me x equaling 3. Now, we forgot to do part A up here. What makes each one of these denominators 0? Well, what number times 2 is 0? It's 0. This will never equal 0, so I don't have to restrict anything out. What number times 3 is 0? So on part A here, x equaling 0 would be the number we need to restrict. We did not get x equaling 0 for an answer. Therefore, this would be my answer. X equaling 3 is my final answer there. All right, very good. Let's try a couple more of those. Notice here I only have one denominator that is the same in this next example, x plus 4. The only thing I have to worry about, therefore, that is my least common denominator. That's an easy one. So every term gets multiplied by x plus 4. And notice this is going to cancel with that, so I'm going to equal a negative 4. This is going to cancel with that, so I'm just left with a 3. But nothing cancels here, but you got to be very careful. You need to multiply negative 7 through each one of those. So distributing comes into play here, and it's very important that you distribute that negative. So now I'm going to combine to solve for my x value. I'm going to combine this and this. Now I'm going to rewrite negative 7x. 3 minus 28 is negative 25 equals a negative 4. I'm going to add 25. Therefore, I get negative 7x on the left because this cancels, equals a 21. Now divide by the number next to the letter. Therefore, x equals a negative 3. Now, I'm circling that answer, but I again forgot to look at part A. What makes the denominator 0? What number plus 4 is 0? Hopefully you're telling me that it's negative 4. Again, negative 4 is not what I kicked out of here. Therefore, this is an okay answer. Okay? All right, let's do part A here on this one so I don't forget. What makes the denominator 0 here? What number plus 2 is 0? I hope you tell me that it's negative 2. And what number minus 2 is 0? I hope you tell me it's positive 2. Again, you can set each one of those equal to 0 if you want. And then notice that each one of those occur here in this guy. So we've already have those numbers in place. All right, so least common denominator. In a case like this, you want to make sure you account for every single expression. But you don't want to account for them twice. This one only occurs once, that occurs once, that occurs once because there's no power. So therefore, my least common denominator on this one is x plus 2 times an x minus 2. Okay, so I'm going to multiply every single term by that. X minus 2, x plus 2, x minus 2, x plus 2, and an x minus 2, x plus 2. Okay, so now this cancels with this cancels with that, and these two cancel with all of that. Getting rid of all those fractions, and that's our goal. But be careful here, I have to distribute. So let's go 5x minus 10 Distribute the positive 3 this time through each one of those. So it gives me a plus 3x plus 6. And I'm just left with that 12 on the right side. All right. Combine any like terms that you can. On the left, in this case, I would get an 8x. Negative 10 plus 6 is a minus 4 equals 12. Therefore, I'm going to add 4 and add 4. And I'm left with 8x equals 16. And that's going to leave us by dividing by 8 both sides. Therefore, x equals 2 would be my final answer. Now, look at the numbers that we restricted in our part up here. 2 is one of those numbers, and that's exactly what I got here. Therefore, it cannot be a possible answer, because when I plug that back into here, it's going to give me a 0 in the denominator of that fraction, which is bad. Since this is the only answer that's a possibility, that means nothing works here. My final answer here will be the empty set. Okay, so there's a possibility you might have those special cases for that. Now, in a case that it does work, I should actually say that here on this problem, that if you got a true statement here, this is for a false statement. This is on the reverse side. That's for a false statement is your answer. But if you have a true statement, say you came down to negative 2 equals negative 2, for a true statement, your final answer would be the all real numbers, that everything works. And that's that funky little R that you see right there. Okay? All right, let's go back to the back side of the first page here and do the last problem. At the end of this section, we have to do some substitutions. So the problem says, find all the values of x satisfying the given condition. I have y1 equaling this, y2 equals that, and I want to know when those two things are equal. So I'm just going to set this equal to that and solve, okay? So I'm just going to go ahead and distribute it at the same time if that's okay to save a step. 21x minus 14 plus the 5 has to equal, distribute your 6, gives me a 12x plus 6 when I multiply each plus 24. And then I'm going to combine like terms, combine. So let's go 21x, negative 14 plus 5 is a negative 9. Rewrite your 12x, and 6 plus 24 is a 30. I'm going to subtract 12x and subtract 12x. Again, I'm going to do it all at once. This goes away. Now, I would have this left over on this side with the x's, so let's get rid of it. Do the opposite by adding 9. And what do I have? That goes away. 21 minus 12x gives me a 9x. 30 plus 9 is 39. And then I'm going to divide by the number next to the letter. Therefore, x equals, well, 39 ninths won't go evenly, but it does have a common 3. So I'm going to divide by 3 on the top to get 13, divide by 3 on the bottom to get a 9. Therefore, that is my final answer. So hopefully this is a good review of what you've seen before with linear equations. Some of these rational ones might be the ones that you need to work on a little bit more. But remember, try to get that least common denominator. That way all your fractions are gone at once, and then you can keep going from there. Okay? Until next time.